right, let's go ahead and finish this example number 12 and talk about what it means that we've just done. So number 12, if you take it quite literally, it means multiply the two functions, which says we have 2x squared plus 3x minus 5 multiplied by 2x. And oops, I ran out of room there. Let me see if I have any more. Nope. So I'm just going to put it up here, multiplied by the 2x. And so that just, of course, says we're going to distribute this through just like that. So my f times g of x is 4x cubed plus 6x squared minus 10x. And that is my f times g of x function. And then f times g of 2, that would say, if we take it very literally, that we're going to take this new function f times g of x and we're going to evaluate it when the x is equal to 2. So we put in 2 for the x's. And then we find out what the value there is. So we have 2 cubed, which is 8, and 8 times 4, which is 32, plus 2 squared, which is 4, and 4 times 6, which is 24, and then minus 2 times 10, which is 20. So we have 56 here, and 56 minus 20, which is 36. Now remember that on the last one, where we quite literally interpreted f of 2 times g of 2 by finding the value of f of 2 and finding the value of g of 2 and then multiplying those to get 36, it's the exact same thing as if we had found the general function and then evaluated that general function at 2. And what we learn here is that the expression f of x times g of x is exactly the same as the function f times g of x. And what this really comes back to is the whole idea of our rule of fours, that we can evaluate and look at functions in a lot of different ways. And this is helpful in the fact that if I want to find f times g of 2 and I have a graph, it says to me, oh, well, if I want to find f times g of 2 on the graph, I go find out what f of 2 is, I go find out what g of 2 is, and then I can multiply those two values, because I wouldn't necessarily be able to find the general expression that I would be seeing here from a graph. The same would be true of tables, right? If I had a table of values for f of x and I had a table of values for g of x, if I wanted to multiply f times g of x, it would be impossible to multiply the two functions together without building their equations and then multiplying them, but it's not impossible to find f of a value and g of a value and multiply them. So it's important that we know that these two expressions are exactly the same with one another, so that we can apply the rule of fours. All right, so that should wrap up section 7.2, and on our next video we'll be looking at section 7.3.